So the most obvious thing to do would be starting with the network. So today, let's start our big review where we're going to demonstrate things to allow us to separate out our clients from our servers. Now, although we would think of a client and a server as being running in different applications, moving forward, we'll discover that it's not an issue of whether we're running with the same code or even running at the command line interface. No, the real issue is where do we keep our brains? Now, right now, our brains in PyTrack 2020 are all local. Everything happens with our application standing alone, but our mission is to relocate that brain somewhere else. And even once we decide to relocate that brain somewhere else, the question is, how much smarts are we willing to put in the server or in the client? And there's even a more interesting option. Would we want a server that can serve more than simply the PyTrack game? And that's the real question, because we can have the same code base, and we will for the moment, but where to put the gameplay? If we put all of our gameplay into the PyTrack server, then that's fine. We have a map, we have the rules, we have the calculations, and our client becomes pretty much a dumb client, what we used to call a dumb terminal, because all it has to do is take a look at what's going on in the server and pull that down. Maybe that's the way we should try. But there's another way, too, which would allow the roles to reverse. In other words, the client, certainly the first client who starts up the server, would have all of the brain power, if you would, and the server simply becomes a turnstile, not even validating what's going on inside the game, and allows us to do other games as well. The problem with putting all the brains in the client, of course, and making our server basically a stupid turnstile that just brokers messages back and forth, is that all of a sudden, the Trek client at least, if not other people, could completely hack our games and do cheat codes and other things that we otherwise wouldn't allow to happen. So the rules we have for our game, where they go, is an important thing to know. As while one gives us a really great unhackable game, the other gives us a game that can be hacked. But if we have the turnstile mode, of course, we have a highly reusable component that can be used for more than PyTrack. The best of both worlds, of course, would be have some type of validation logic that would allow the first client to program up the service with the rules of the game. And although it would be very difficult to do every rule that we see in PyTrack in that grammar, it certainly is a hybrid mode. In other words, the server would be able to detect someone cheating or hacking and be able to enforce the rules not only for PyTrack, but for Battleship, chess, checkers, Stratego, Risk, or a dungeon crawler, based upon a grammar that we define. So we're talking about another bunny hole here, another project that could become an open source way of doing business, either a slave, a master, or a programmable master, for lack of a better. And moving forward, all we're going to do is simply put the brains for PyTrack 2020 in our server and make our Trek clients pretty stupid, which of course will raise some challenges for our administrative capability or our testing capability or testing client. Before we get to those options, however, let's take a look at how we are definitely going to want to have our Trek client talk to our Trek server. We have to use some way to broadcast information out into the ether so as to allow small packets to query back and forth to tell us where the servers are and where the client is, as well as what version of protocol we might be running. I like to use UDP/IP. Once, of course, we understand where we are and we've completed that protocol, of course, the next thing we have to do is allow the client and the server to communicate to each other. And that's another protocol we have to figure out. And all of this needs to happen pretty much automatically, as we see in modern games, whether we're working on our local computer or to some other's game server. That's something we can certainly do. But by way of a best practice here, we're going to also specify using the HTTP codes. Now, we don't have to be using HTTP. From success to redirection or access denied, we have all the codes we need, and they're easy enough to convert to integers. So let's go ahead and assume that no matter what we're using, whether it's TCP or UDP, our application will be communicating those codes that we usually see with web pages rather than every socket capability. So let's take a moment and hack a server, begin using a console or ARGV way of looking at business to help inspire us or encourage us to confidently code where a few Pythoneers have coded before.